All right, this is still section 6.1. We are going to go ahead and take a look at the ambiguous case. The ambiguous case is when you're given information about a triangle, you're given two sides and the non-included angle. And there actually are times when maybe the measures that you're given do not give you a triangle at all. So there's no triangle that exists. You might have one triangle, or there's still a possibility that you might have two triangles. Here's what each of these might consider here. You've got an angle given to you, and this angle here, it doesn't matter what the measure is, but that angle is given to you, a side and then another side. Well, what happens is and granted, I probably drew this a little bit too long, but what happens is that one of the sides that you're given, it just might not be long enough in order to actually make the triangle. Okay, so you got two sides, one angle that's not included in, and the one side opposite the angle is just not quite long enough. In fact, if it rotated through here, it wouldn't be long enough to actually intersect the bottom of this triangle. So that would be no triangle. What happens is you would get an error in your calculator while performing the law of sines. One triangle, we've worked with problems like that, but let's go ahead and look at what happens when there's a possibility of having two triangles. So two triangles here, this is what it would look like. So we've got one triangle. You are going to be given an angle and two consecutive sides. This one side here that we've got, actually this side right here could actually be rotated like a pendulum, and so that it intersects in here. And these would be the same measures. These two sides are the same. It creates an isosceles triangle if you rotate it through. So basically what we're saying here is that this could be angle B, let's say, and then if there's a second triangle, this angle B would be in here. We call it B prime. And so there's the possibility of having a second triangle. It's because whatever this measure is, you actually could have the relationship occur in two different places. And the reason why that happens is because sine is positive in quadrant 1, which is what we get from the calculator. You'll always be getting an angle measure from quadrant 1, but it's also positive in quadrant 2. Well, the calculator is not going to give you quadrant 2. The calculator will only give you quadrant 1. Okay? All right, so here's what we're going to do. We're going to look at some cases where we might have to look for the ambiguous case, and here's how you do it. All right, you've got, again, let's put up a scenario here. You're given angle A, let's say, and you're given side little b and side little a. So I would have to find angle B first. So you'd find the missing angle. That angle is going to be angle B. So we find B. You subtract it from 180. And if you have another triangle, then this angle would be right in here. This is B prime. So if you take angle A and you add it to angle B and it's less than 180, right here, it's smaller than 180, then you do have a second triangle. Now the reason why that works is because if angle A is smaller than angle B, then when you add its supplement to it, you would still have a triangle here where there would exist another angle C on top. If you have two triangles in your problem, you do need to solve for both. All right, let's go ahead and look at some examples. I always put my angle here at the bottom whenever you're given a angle and then a side, so 5 and 21. This is angle A. This would be angle B opposite the 5 and C on top and little c on bottom. All right, so we start off by finding angle B. So angle B we would find by taking 21 over the sine of 26 equals 5 over the sine of B. Now what happens is that for this problem what we get is we get that angle B is equal to 6 degrees. Let's go ahead and finish solving for this triangle. So this is 6 degrees. All right, now in order for me to find angle C would be 180 minus the 26 and minus the 6, which is 148. You can see that I rounded this 5.99 to the 6, so just to keep it a whole angle at this point in time. And then side C, I can do 21 over the sine of 26 equals C over the sine of 148. So you set up your proportion, solve it for C, and side C would be 25.39. So there's our first triangle right there. Okay, if there does exist a second triangle, it would be located right in here. And the angle would be angle B prime, right in here, would be equal to 180 minus 6. Well, that's 174. So let's just suppose that that was 174. The problem with that is 174 plus 26, the original angle, is greater than 180. So this triangle, this right here, does not exist, that part of the triangle. So there's not a second triangle. The only thing that we have is one triangle, and those are the measures. Another thing that you can do is, if your angle that's given to you, right here, 26, if that's bigger than 6, the angle we found, you can't have a second triangle. Let's try another one. We've got angle B is 78. Let's go with this as angle B, 78 degrees. Side B is 5, which would be over here, and C is 12. So now you see how I always put those measures in that way. Anytime I'm given two sides, one angle. This would be angle C, and angle A is on top. So we're going to find angle C. So 5 over sine of 78 equals 12 over the sine of C. You solve this for C. Of course, when you go through this, just to let you know, you do sine of C would equal, it's 12 times the sine of 78 divided by 5. You get sine of C equals 2.3476. So if you try to do inverse sine of the 2.3476, this gives you an error. This is how you solve for an angle right here. This is how you solve for an angle. But we get an error. So since there's an error, then there's no triangle. All right, let's look at our last problem. Let's go ahead and set up our triangle. We've got an angle of 29 degrees. Side opposite of it is 6, and B is 10. I'm going to put the B there, so that makes angle B on the bottom and C on top, little c on bottom. Let's find angle B. So angle B is found by taking 6 over the sine of 29 equals 10 over the sine of B. So you go through the calculations and you find that angle B is equal to, let's go ahead and round it to 54. You want to make sure that you're doing the calculating. Okay, so if I put 54 in here, then I'm going to go ahead and finish solving this triangle. Okay, so C would have to be, then you take 180 minus the 29 and 54, and we get 97. Now let's find side C. So it's still 6 over the sine of 29 equals C over the sine of 97. So little c ends up being like 12.3. All right, there's our first triangle. Now, if there does exist a second triangle, then here's where it's going to be. It's going to be right in here. And this 54, you do B prime would equal 180 minus 54, which that is equal to 126. So this would be right in here, 126. So what we have to do is ask ourselves, 29 plus 126, is that less than 180? Yes, it is. So we will have a C prime. C prime is going to be finding the upper angle here, C, so subtracting 180, 126, and 29. That'd be 25. And then little c also. So we're looking at this triangle right now. This is 126. This is still 6. This is still 10. And this is 29. And we're finding angle C and little c. Okay, so you go ahead and set up for little c, and it would be 6 over the sine 29 equals little c over the sine of 25. And little c ends up being 5.2. There you have it. There's the results for the second triangle. For the second triangle, you'll notice that we use the prime here, this little prime, to indicate the difference between the first triangle and second triangle. Now your assignment for this first section is page 398, 1 through 4, 7 through 10, and 15 through 20. And that concludes the law of sines.